Hey, we've probably all read about SQL Slammer, and some of us have been around long enough to remember dealing with it firsthand. But here's a person who really had to deal with it firsthand at Microsoft at the time. I've got a guest, Aaron Turner, coming on board. You're going to love this. Hello, and welcome to another episode of CISO Tradecraft, the podcast that provides you with the information, knowledge, and wisdom to be a more effective cybersecurity leader. My name is G. Mark Hardy. I'm your host for today, and as I had mentioned, I have my guest today is Aaron Turner. And you lived through some of the biggest worms while working at Microsoft, and I can't wait to hear your story.
Thanks for the opportunity to be here. There are folks that are young enough that didn't have to live through those things. And so my goal in telling these stories is to hopefully impart some knowledge to say, hey, we might be on the path to have a repeat of some of these things. And so what can we do to maybe stop that?
Well, when I went to the War College, both Army and Navy War College, we studied Thucydides, the Peloponnesian War, particularly in the Navy War College, because I figured that nobody really had emotional vesting in Athens or Sparta this many years later, but a lot of the lessons still were true today. Now, a lot of people in the industry are kind of obsessed about mean time to respond, MTTR and things like that. But if you go back to 2003, that really wasn't an issue. This thing had been around in terms of vulnerability for a while. It got to at least 75,000 hosts in 10 minutes. And while some people say, hey, that's not that many in today's numbers, back then that's a pretty huge chunk of the internet and things such as that. And by the time the first pager went off, the damage was already done. So you were there in the room at the time. So at that point, we were dealing with human speed response, not automated or even AI response. What happened? Tell us a little back about what happened in those days.
So first we need to set the scene, right?
Okay.
So, Microsoft in the late 90s did not have a fully functioning dedicated cybersecurity team focused on software. Right? There was a small team that was focused on some internal stuff, but there really was not security quality assurance for our outbound products, and it showed. Right, you had significant exploitable problems from the garbage that went out through IIS, from NT4 to what got later on to Exchange 2000, and SQL Server. Essentially, what happened was Microsoft released SQL Server 2000 and said, we want a SQL Server everywhere. Let's get these things everywhere. Gas pumps, ATMs. You want a SQL Server in your car? We'll do that too. They developed a super lightweight version of SQL Server that would sit on an embedded system. Well, the Microsoft product people were great, right? They got these SQL servers put everywhere, millions of them. And I think your definition of the 75,000 hosts, that was what you saw for a publicly hosted
Right.
IP address, right? There were dozens, if not hundreds, of SQL servers behind the scenes that were infected, but you just didn't have a publicly attributable IP for it. So, we estimated that. So I was on the team that also had to respond to Code Red in 2000. So, if Code Red took down, 2 million different hosts, NT4 hosts out there, SQL Server, by the time the middle of February rolled around, it was probably in the tens of millions of SQL servers were out of control. And so no one ever thought about the operational requirements to make sure these things stayed patched. And so by 2002, the Litchfield family, if you've never heard of them, David Litchfield, both senior and junior, did some awesome work back in that time frame. They had basically said, hey, this is a problem. They helped us to lean into fixing it. And there was a very fruitful relationship that happened between the Litchfields and Microsoft as a result. But by 2003, some less than ethical folks had discovered the problem, had written some very elegant code to take advantage of it. And this was back in the day when there was not necessarily as much self-governance over the attackers. Like attackers today, like if you went to a ransomware group and say, hey, we're going to take down the internet, the ransomware guys are we're going to kill you. Right? We need the internet to run our ransomware operations, right? And so back in those days, there was not such self-governance. And so a lot of these incidents aired on the side of denial of service. So what ends up happening is the worm starts early in the week. By Tuesday, I think, basically most of the U.S. banks had lost control of their debit card systems. Sections of the public telephone system were useless. You couldn't make long-distance phone calls. There were times, in fact, at Microsoft our internal SQL servers were so offline, I actually had to build a ticketing system that kept track of all of the inbound calls at Microsoft under my
Wow.
desk, right? Because nothing was working. And it all happened because of the mass proliferation of SQL servers without appropriate controls, without appropriate thought of how are we going to patch these things? How are we going to maintain them? Can we get in the middle? Do we have a compensating control? Um, does this sound familiar when it comes to things like AI agents or MCP servers or anything like that?
Yeah, I see what you mean about the past holding lessons for the present. So let me back and just backfill a couple things. Probably 90% of our audience knows this, but for the 10% that might be scratching their head a little bit, SQL Server. What is it? What does it do? And briefly, kind of like a Feynman definition.
Yep. So relational database. Basically, what was happening before that, you either had super expensive Oracle servers that you had to
Hmm.
go and use for a relational database, or you had Access, Microsoft Access, which was essentially a desktop database that wasn't great. And so SQL Server was essentially taking the Microsoft business plan of providing very low cost software relative to Oracle, and making it available for lots of people. And so a relational database put everywhere.
Yep. And SQL, structured query language, so everybody would agree on the exact way. Once you learn a SQL, if you will, then it's good to pretty well everywhere else. And of course, the SQL Slammer worm, we're not going to dwell on that, but that was only 376 bytes of code. It's all written in assembler. And I guess when you throw in the layer 3 and layer 4 packet headers with the IP and the UDP, it came to exactly 404. I can't find it, right? It was a little bit of a kind of a hidden joke, not deliberate. But really all it did is it just sent itself copies and copies and copies of itself to everything it could find on just kind of a randomized IP address. And back then, you didn't have everybody blocking themselves with firewalls necessarily. So if you had UDP port 1434 open to the internet, guess what? You had an unwanted visitor. So let's kind of pick up and off the past and think now a little bit about what you had started talking about, which is AI. Are we going to repeat the same mistake deploying AI through our organizations?
When Anthropic released MCP, their MCP platform without
Mm-hmm.
authentication, I went, we are inviting disaster. And I don't know who wrote MCP at Anthropic, but it was probably some younger individual that essentially vibe coded the thing together. And it was probably a good idea for whatever he or she was working on at the time.
Mm-hmm.
But when you release something without an authentication or authorization layer, that's bad for the internet. Like that's not what I would call responsible behavior. And they've done the same thing with Claude Desktop. Now, OpenAI is not much better. Grok, even worse. Gemini, right? So like no one's doing this right because everyone's out there for the sake of market share, right? They're
Yeah.
releasing this stuff to go, hey, let's conquer the world because we want people to use our platform because that's how we're going to get our next valuation to raise $10 billion of capital to build the next AI data center or
Yeah,
whatever.
speed to market.
Yeah, and so the business says that we have to deploy this stuff. I was just on a call. I serve as IANS faculty, and I was on a call with an IANS client, and we're talking about a a banking transaction system that is important. Right, that this is not something that prints T-shirts or whatever. This is the banking transaction system. Their business leaders have told them that they have to deploy AI this year. They haven't said, well, we're going to do AI right. It's like, we're going to do AI fast. And so when you have situations like that, where business leaders are like, we must do this or else we're going to get left behind, that means that, you're going to have to make a decision to say, okay, well, that is a risk. And, you, do you have the controls to basically try to keep things on the rails if you're going to have to do that? So that's the hard position that cybersecurity leaders find themselves in. You must use it. The technology is not mature enough to do it. So that means that you essentially have to build some business continuity disaster recovery processes to build the
Yeah,
gap.
so we're basically have automobiles, but no seatbelts yet, and no airbags and no anti-lock brakes. But for decades, we drove vehicles without any of those safety systems that, of course, suffered the consequences as a result of perhaps unnecessary death and injury. Well, as we look at AI, though, and where we're directing our efforts, of course, from a defensive perspective, cybersecurity professionals can build stuff. But what about the attackers' use of AI? What are we seeing there, and what are the consequence for us as the defenders?
So when I left Microsoft in 2006, I joined a group at the Idaho National Laboratory that was tasked with proving that we could do physical destruction with a cyber attack. And we did. We blew some stuff out on the Idaho desert, and it took us a year and a half to develop the plan and the exploits to do that work because it was tedious. You had to decompile software. You had to look for problems. Like it was this very long, tedious process. Last year, I did a bake-off between Claude and ChatGPT. I basically said, here's a sample software. It was an industrial control software. Here's a potential attack path. Walk me through how to do this. It was 15 minutes. So what took us a year and a half to do in 2007, it took me 15 minutes to do last year. And so not only that, but Project Mythos, I don't know how much is real, how much is marketing, but I think there's some reality there. Like it's not very often that a technology announcement causes the Secretary of Treasury to do a banking system briefing, right? So
Yeah.
I'll say that there's enough there to at least merit some attention. So let's say that you're doing a good job patching Windows servers or Linux servers with 4 critical vulnerabilities a month. Okay, good for you. Awesome. And you're doing that on a monthly basis because generally exploits take about 21 days to reverse engineer. And so, okay, you can patch, you can do it before the exploit gets developed. And so you're okay. My friends inside of Microsoft have said that we should be ready for 120 criticals a month starting later this year.
Wow.
So if you're patching 4 and you're now trying to do 120, like what's your regression testing process for that? Like, can you regression test? Like, I actually got started in this line of work because of the movie War Games with Matthew Broderick, and it motivated me to do some things I probably shouldn't have done with computers. But that movie has a sequence of images and where it says, "Do you want to play a game?" Right, that's the computer asking a question.
Right.
And I do not want to play the patching game anymore. I think
the global thermonuclear war of patching is just the only winning move is not to play. But so it brings up an interesting question, and I think you framed it nicely, is that as we move forward, we're going to have to go ahead and get faster and be able to go ahead and realize that we're going to have a lot of these potentially critical vulns. They may get identified, what I call the democratization of the attack surface or the attackers, because now you don't have to be a nation state to be able to do this. You just have to have a handful of tokens and be in mom's basement with some Mountain Dew and a pizza, and boom, you got a 0 day. We're going to burn through a lot of those things over the next year and a half or 2 years. It's going to be tough, but it's a whole new game changer. But take us back into the Redmond reality back in the late 1990s. What was the culture like about security? Was it an engineering tax that everybody sort of had to pay? Was it ignored before Howard Schmidt got there? Was there anybody who had the power to stop the ship? And were you there when Howard showed up, or was there somebody even before him who changed the model there?
So I got hired in 98, and I had a passion for security because of my War Games related stuff. I was essentially, I was probably the closest thing to a gray hat at Microsoft. Like I had not really gotten in big trouble, but I had wandered into certain parts of the world. Like I had an account on Cult of the Dead Cow. I was interacting with some of the folks at Loft, and so I knew what was going on in that ecosystem. But it was very, very clear at Microsoft, thou shalt never. So Cult of the Dead Cow developed this thing called Back Orifice. It was a way to root.
I remember that. Yeah.
It was very clear, thou shalt never run Back Orifice on Microsoft stuff. Like you will never bring that hacker evil crap into work, right? So there was this, and also you were never to speak with anyone who developed exploits. You were never to share security updates with people. Back in the late 90s, the only way you get a security update, you had to call, validate your key, your Windows key, and we would email you the security update because the security updates were so important to keep secret, right? We didn't want people to be able to update themselves, right, or to have access to it, because that would give the bad guys hints where the security problems are. And so it was like it essentially pushed security in a place like any black market where there was no appropriate place to talk about it. And it wasn't until Code Red in the summer of 2000 when me and this guy named Rob Hensing, we were basically going, we were very junior people at Microsoft. We were part of product support services, which are the telephone support jockeys, right? Like we were the ones handling these inbound calls, right? 2 million customers who need a patch, and we have to talk to each one of them and make sure that, and then send it to them, but their email's broken so they can't get it, and we don't have a website to download it from, so we had to burn a CD. FedEx made a lot of money that summer. If I would have made a stock bet, it was like we would move the needle for FedEx because we shipped millions of CDs as a result of that. And so that's the culture, no central organization. And even when Howard came, Howard was set to the side to say, "Oh, you're a pretty security guy. You can't tell us in Windows what we're going to do," because the Windows team, Jim Alchin and friends, were so all powerful. And so Howard was there, but he was a totem, right? He wasn't really driving security into products yet. And it wasn't until we lost the source code in 2000 to the Russians. In October 2000, we had the big incident where the Russians stole the source code. And it wasn't until then what we really started to get like internal cultural security. And that's what Howard oversaw with some other brilliant people who did some of the first implementation of smart cards and things for MFA. And so by 2002, because of the events of 9/11, we got some ability to move forward. And then by 2003, we at least had Windows under control, but SQL and Exchange and Office weren't under the umbrella. We had Windows Update, but we didn't have Microsoft Update. So we had a scalable way to go after Windows, but we didn't have a scalable way to go after the app stack, right? And so that's the progression, right? From volunteer firefighter, where there was like a dozen of us in the late 90s, to where we actually had a team that was focusing on this in the 2002 timeframe, to global catastrophe in 2003. Like that's the progression.
Wow. Yeah, I mean, these days we're thinking about agentic security. How do we take AI, which can, in the LLM format, simply just answer questions? And the worst it could do is either compromise your input because it shares it with somebody else, or mislead you on the output with respect to having a bad hallucination. But today, it's a big deal because we're looking at empowering AI to do things. Now, back in the days that you're talking about, you didn't have any of that. You didn't have the telemetry necessarily. You didn't have central reporting. As you said, you didn't even have a way to evenly distribute updates for things. How did you diagnose like a global worm? How do you get the insight when there's just reports coming in from overseas? It looks like something might be going on.
This is back in the day when Microsoft was dominating with Hotmail. And so it was interesting how Hotmail served as one of our early indicators. So Hotmail being up and running, right? That was like, hey, okay, if Hotmail has problems, there's our early indicator, right? Mainly from a DDoS perspective, because Akamai had just barely gotten started. Like there was no real ecosystem for global internet management at the time. In 2001 is when we released Windows XP, and Windows XP had this little nugget of goodness called Watson. It was the Windows remote reporting environment.
Oh, yeah.
So when something would crash in blue screen, as long as it had a TCP handle, it would send us the crash. We got a lot of really interesting stuff, like because we'd get the whole crash dump. Let's just say there were some images sometimes involved that we didn't want to see. Right? There were sometimes very sensitive documents involved in the crash dump, but it wasn't until 2002 until Windows XP actually got to scale that the Windows remote reporting system was actually valuable to us. And so, it was basically raw internet telemetry that told us, and then Watson would give us early indicators of, oh crap. So by the time Blaster hit, for example, we had early indicators of like, uh-oh, someone's going after the RPC remote vuln, and we'd better be ready for that.
Interesting. So, I mean, I remember you're talking about old stuff and you're going to be going through things. I remember when the I Love You came out back in May of 2000. I had just got back from duty out at U.S. Pacific Fleet. We were writing the fleet firewall policy, which I thought was pretty good that the Pentagon delegated it out to the fleets to say, you're going to have to live with it, so you write it. And so as a reservist, I'm out there working on it. Then Monday morning, turn on my computer and fire it up, and there's about 13 emails. The first one from Bruno saying, I love you. And it's like, maybe not. And then poke around a little bit more. It's like, yeah, something really interesting is going on. Well, at that point, I'm 6 hours ahead of Hawaii, and I call back and I get a hold of Watch Center, and I said, there's a digital tsunami coming your way. You better go ahead and block this, because one of the things the Navy used to do is we would put distribution lists, and we would begin with a hashtag or an octothorpe if you want to go ahead and make the Brits happy. And so the first 50 addresses in your address book, which is what I Love You would send it to, might actually be 50,000 addresses, like all of this, all of that. And so it just went on steroids. And interestingly enough, although the military had all these commands that crashed, U.S. Pacific Fleet did pretty well. And it's probably because of some random reservist calling them at 2:30 in the morning local time and say, this is coming your way. So If we take a look today, though, and where there might be some potential blind spots, that was just coming in on email, and we're talking about UDP and stuff like that. But how about like the open RPC ports back in 2003? We got anything like that today in our AI stack?
Well, let's use your analogy back towards the email worms. So
Right.
inside of Microsoft, let me give you insight into how we respond to that. So when Melissa and I Love You and the other self-propagating email worms came out and exchanged so hard, um, the practice was you would go to a printer, open the paper tray, pull out a piece of paper, take a magic marker, and write "Do not open Outlook," and you would put that on the front door. That was
Yeah.
the security control.
And put it by
Okay?
the coffee pot.
Yeah, don't open Outlook. That was the security control. Okay, so what's the equivalent now? Well, unfortunately, I'm going to walk through a sort of 4-phase approach here. So number one, if you're in an organization that allows multiple browsers to work, like let's say that you say, oh, we will let Chrome and Edge and Firefox and Safari. We're a browser heterogeneous environment. You're insane, because the browser is where AI is going down right now. So step one for a mature security organization, get to one browser, choose one. And the way I suggest is wherever your email lives, use that browser. So for example, if you're Exchange Online, use Edge. If you're if you're Google Workspace, then use Chrome. And so that's step one. Get browser hygiene, because browser hygiene is going to give you the ability to monitor what is happening in those browsers. Step two, the days of VPN and proxies are done. Like, that whole technology stack is not helpful when it comes to AI. You need per TCP session monitoring of what every browser extension is doing, and that only comes with SASE. So that means that you need full-blown SASE on the endpoint right now. Zscaler, Netscope, Palo, Prisma, whatever you're going to do, get it done. Like, get it done yesterday. The next one is identity is where it matters right now. So for example, let's say that you've got Claude Desktop deployed. Claude, the people at Anthropic have refused to use on behalf of tokens for Claude Desktop, which means that Claude Desktop uses your identity to go do what it needs to do. If it goes access a PowerPoint deck or Excel spreadsheet, whatever, you can't tell the difference between whether I did it or Claude Desktop did it. Now, they say that they're trying to do some things there. I was on a call with Anthropic last week where a major insurance company threatened to pull a $50 million deal from them because OBO wasn't working. And Anthropic's like, deal with it. We don't need your money. Like, this is a $50 million deal. If $50 million can't motivate them to do security right, it's just going to have to happen whenever they're ready. So that means you need ITDR, right? Identity threat detection that is at the speed of AI. I've been working on this with a couple of folks. If you're interested in this, connect with me on LinkedIn. I've got 2 active projects proving this right now. I would be happy to share that research if folks would like.
Interesting. Yeah. So it's, $50 million is not worth moving. I remember when I was doing some work with a very large bank in America, but I'm not going to mention the name, that we were trying to do some security commencement project. And they said, yeah, if it's under $500 million, it's not big enough to move the needle. The fact you can come in and save us 20 million, yeah, kind of nice, but you're not going to meet the threshold. We've got things that will save us a whole lot more with the limited time that we have and things like that. And so as we go back and try to draw from these lessons from the past, as I mentioned about SQL Slammer, pretty simple. UDP, 376 bytes of code, written in assembler. No handshake because UDP is unidirectional and things such as that. Did that make our playbook defense irrelevant because we weren't there looking for the SYN, SYNAC, ACK, and the exchange and the handshake and the TLS and this was all just boom, fire and forget.
So you were configuring firewalls back then. Think about the processing power of a firewall back then. Like, it could barely do simple port blocking, right? Like, you did not have either the memory or the processing power to do application inspection, even to break open, layers 5 to 7 above, right? Like, you could barely get by with layers 2 and 3 to go, oh, this looks like a good packet. Okay, I'm going to let this through. So because of the primitive nature of those devices, we didn't have the horsepower to do any sort of inspection. So UDP, in most cases, people didn't even know what that was. Like there's a whole segment of enterprise firewall administrators who are just focused on TCP. right?
Hmm.
They were looking at anything that was connection oriented. You talking about connectionless, like broad UDP broadcast events? Like what the hell is that? And sometimes I would have to educate people about UDP packets in the process of doing this. And like, wait a second, there's a whole nother internet here. I'm like, yeah, UDP is this whole other internet you got to worry about.
Hmm.
And so if you think about what Slammer did, and if we use machine guns as the analogy, Code Red, which we still don't have firm attribution, but I believe was probably Chinese at least started, right? Because of what happened geopolitically in that time frame. So if the Chinese released an AK-47 with Code Red, Slammer was the equivalent of like a Vulcan Gatling gun, right? Those big GE things are at the front of an A10 Warthog. That's what Slammer
Hmm.
was, right? High power, super super effective, blowing the crap out of anything that it touched. Um, and that was essentially the jump in technology where the bad guys had figured out how to go from an application layer attack like Melissa and I Love You to you mentioned it, like this was written in assembler, right? This was a super super efficient attack, like nothing. Yeah, so that was the jump forward from an attacker perspective.
Yeah, because I remember Code Red. You talk about geopolitics, and with China on the 1st of April of 2001, a U.S. EP-3 collided with a Chinese J-8 off of Hainan province. And that kind of started the great patriotic hacker wars, if you will. And so by July of 2001, it was kind of off and running and things like that. I remember in September of 2001, we had the NIMDA worm. I was called back to active duty after 9/11. And then 7 days later, we get this outage that just goes throughout everything. And we're like, exactly what we did. We photocopied things, put in the coffee machine, the restrooms and stuff like that. Like, do not open your email, do not click on this and things like that. And of course, somebody did. And we're like, oh, come on, really? And so we've been up all night long, no shaves, no sense of humor. And this one lady, it was like, did you click on that thing we told you not to click on? She goes like, yes. It's like, why did you do that? And she's like, everybody was talking about it. I had to see what it was. It was a Pandora's box moment where somebody just wanted to see, this looks interesting. I want to hear about it. So sometimes, in spite of your best preference or defenses, people are going to click just to take a look. Okay. So when we had things that failed back then, it was kind of universal. ATM networks went down in some cases. Different corporations were unable to stay up and running. In fact, I think 3 of the root servers were taken out of the 13 DNS. But how about today when you have a CISO who's got a situation where we think about CIA, confidentiality, integrity, availability. Most of the time we worry about loss of confidentiality. Integrity means something bad got in there. But availability, if things go down and you can't get the business done, what happens? What was it like back then?
Well, so first, I think it's super important that people understand the human cost of what was happening back then.
Mm-hmm.
Okay, so for example, I didn't see my kids for 2 months when Code Red went down. I didn't see my kids for 2 months when NIMDA happened. I lost my wife had just given birth to our third child when Slammer happened, and I didn't see her for 6 weeks. So I think people don't understand the human consequences of what happens here. And so back then there were not CISOs. There was
Mm-hmm.
not even like someone. I don't think we even had director of cybersecurity. We had network security engineers, right? Like
Right.
there were these people doing NetSec, or there was a firewall admin, or whatever. Back then, less than 25% of enterprises had a patch management program.
Yeah.
Like, so I think you what happened was everyone looked at each other, and I guess to a certain extent it was good. Um, there wasn't really heavy consequences. I don't recall anyone getting fired as a result of
Mm-hmm.
these things because people were like, "Oh, well, that happened. Okay, well, I guess we need to start planning for this." And then people started getting more mature and that sort of thing. Um, and so, because of the lack of consequences, um, people pointed at Microsoft and said, "This is your problem, right? Like, why did you do this?" And to a certain extent, it was Microsoft's problem, right? I mean, you're releasing this crappy software, and you got problems. Yeah, you need to take some responsibility. Um, Within Microsoft, we created this program called Make It Right. And like any good
Mm-hmm.
program, it has an acronym. It's called MER, right? So the Make It Right program. And we spent fractions of billions of dollars over those few years, basically paying customers off to go, please don't sue us. Oh, you need a new data center? I remember during the blaster worm, I used my Microsoft Amex to buy an entire data center worth of hardware from Compaq that, and then I had to rent a private jet to get it shipped somewhere. And so I got some good Amex points off of that.
I was going to say, you get to keep the points, and you're probably good for life at that point. Well, hey, today we got AI that can develop stuff at, develop payloads and then just launch them at machine speed. We're no human in loop. There's nobody sitting around coding away, looking for vulns going, Eureka, I found it, and things such as that. Are we getting to the point where you mentioned companies that don't have patch management programs? Does patching really matter? Because we're always going to be time late. So what do we do? Do we just kind of suck it up and take the hits, or is there a better strategy?
As I mentioned before, I do not want to play the patching game anymore. It is not a good outcome. And so what I'm doing is I'm using the power of AI to refactor legacy code and make that stuff serverless. So for example, I think it's a better bet to say, I think Microsoft and AWS and GCP are going to invest to keep their systems as good as possible. And so if I can get my stuff loaded into their serverless architectures, that's good. So for example, I helped a big natural gas provider in Europe. We found 200 applications that could not be patched anymore. Like basically they're all old versions of Windows or whatever, old versions of Linux. And we took those, in this case, Copilot was their authorized LLM. We took the code from those, the data structures, put them into Copilot and said, what would be the fastest way to move all of this functionality into the Power BI platform? And with 170 of them, we moved those apps straight into Power BI. We just shut all those servers down, right? We just turned them off, put bullets in them. And you have to use the power of AI to refactor your technology to get out of this game. Like that's the only logical outcome there is right now.
And that makes very good sense. And that would be probably part of what would be called cyber resilience, being able to go ahead and create good defenses and things like that. Now, sometimes we get our budget, we spend money on manual processes. We feel that they're useful, but you don't get any leverage on it. It's just one for one return on the human. And it's almost like a high functioning self-sabotage. We're spending money on something that's plodding along like an old ox pulled cart in an era of rocket machines and things like that. What are we doing here? And how do we clean up our act, so to speak, to be able to move at the speed of the threat?
So I've been fortunate to get invited by a couple of private equity firms to go and try to do cybersecurity at scale. And in one of those engagements, I was invited to become the interim CISO for a technology company held by a private equity firm. And when I got there, I will generously state that there had been a lot of elaborate acts of self-deception. Okay, and an elaborate act of self-deception was this in this person's case, my predecessor. This person had created a very great looking PowerPoint deck about vulnerability management that they had presented to the audit committee of the board of directors. None of it was true. Like when I went to go suss out the details, it's like, that's an order of magnitude off. Like, this is just not right. Now, this person, I don't want to say that they were outright lying or misrepresenting, but they, because of the resources they had, because of the rules of the game they were forced to play, they presented the data in the way they did to stay sane. Right? It was the mechanism that they used to say, this is my reality, therefore this is my program. And so they reverse engineered it. They were afraid to state reality because of the consequences. And so I think you've got it. It is super important now for anyone who's a CISO that, unfortunately, you've got to throw caution to the wind and go, you know what? I don't really care if I lose my job. I'd much rather be honest right now and talk about the outcomes here. And unfortunately, a lot of folks have done that, and a lot are looking for work now. Like I hang out in some of these Slack channels where people are looking for work where they've been punished for being honest. But I think, unfortunately, that's what you have to do. So the tooling is going to have to change, right? Making the endpoint super flat, daily updates for endpoints. You're going to have to do that. Daily endpoints for browsers. Like every time a browser gets updated, you enforce that. The days of EDR are numbered, right? I don't think EDR is a successful tool that's going to help us here. You need NDR, you need CDR, you need ITDR, right? These are not EDR related problems. And so I think it's going to be super important that either the EDR players are going to have to make massive acquisitions, or we're going to have to go and self-source that.
Yeah, it's interesting. What I tell people is that if you have to deliver a message like that to the board, you suspect that they like to shoot messengers. There's a very important message to include in that message. And it's kind of a grounding and said, look, I don't want to tell you this, but I'm going to. And you don't want to hear it, but you're going to have to listen to it. And your first response might be to be angry at me and said, you're out of here. Here's the problem. You do that, nobody will tell you the truth from now on. And you could lose this entire organization and compromise all of your fiduciary responsibility with the legal consequences that comes from by shutting off your input of honest baseline truth. So, do you want to go down with the ship? Throw me overboard first, and guess what? I'm tied to the anchor. Otherwise, keep the honesty, keep that communications open, live with the consequences, give me the tools to fix it, and we'll save the ship together. Now, that's kind of pretty forceful when you're talking to someone that's a lot more powerful than you, but at the end of the day, you got to help them realize that, like a ship, and I deliberately use that analogy, being a naval officer, ship sinks, you all get wet. You all go down. It's not like being in something else where the truck breaks down, okay, you'll walk, and things such as that. How about, okay, let's skip ahead a little bit because we're trying to make sure we meet our time commitments here. How about AI native compliance? And this has a AI 600 TAC 1 standard. Let's compare the old check in the box. What do you think about this?
So number one, I have been super disappointed with NIST's work here. Okay. What they have done around AI in the past was not fit for purpose for most of the enterprise. It was really good ivory tower stuff if you were OpenAI or Microsoft or Anthropic, but it was not meaningful. Now, what I do like about 600-1 is that at least they're saying, hey, let's apply the good old NIST cybersecurity framework to this, identify,
protect, detect, respond, recover.
So, but it's like, I didn't need you to write something for that. Right? I already know that, right? So and I think if you're trying to comply with it as an absolute mechanism, you got better things to do, right? Focus on your control plane. Don't focus on just the mere aspect of compliance with the NIST standard. Now, I am biased, and this is a plug for IANS. IANS is a vendor neutral place. Mm-hmm. We try to provide some very specific things about, hey, here's your control plane. Here's how you discover. Here's how you quantify. Here's how you use AI to protect yourself. And so I think if NIST is going to be helpful here, they need to get that level of detail. And so my feedback to them would be, hey, great. So you copied and pasted the CSF into the AI. Awesome. I could have done that in an afternoon. Where are you going to help me get specific? And that's what we need to get to, is levels of specificity.
Yeah, maybe you got to bring Ron Ross out of retirement and go back and make stuff happen. Well, hey, if we look at threats going forward, what's our modern, what's going to be the slammer of 2026 or beyond? And as we go from scripts to agents and things like that, we get malware that isn't just pre-programmed and it just fires off at a pre-program. It can pivot, it can think, it can masquerade and things like that, and even screw up with your CI/CD pipeline. What do you think?
When I was an interim CISO, I had an enterprising developer who stood up a CI/CD pipeline dedicated to deploying a new MCP server a day because we were stopping him. So, basically where the inmates are running the asylum and they're running with scissors. And so the speed with which this stuff is going to flex is going to be ways that we haven't had to deal with in a long time. I don't think we'll see a massive denial of service event like Slammer again, just because the attackers self-regulate much better, right? Literally, the ransomware operators in Russia would threaten to kill people who said we're going to bring down the internet because they need the internet to run their business. Oh, yeah. So I think these massive robotic attacks are going to focus on poorly configured AI components, probably starting with MCP servers, just because they are so poorly designed. They're connected to everything that matters. They don't have appropriate prompt controls. They don't have response logging turned on because that's expensive. Why am I going to log that? Well, it's because you better know what's going through that pipe. So I think the other side is the rapid exploitation of vulnerabilities. We talked about, what used to take me months sometimes to develop an exploit is now done in minutes. And so the speed with which exploits are going to come down the pipe are going to be critical to think about. And we've already seen small scale instances with the NPM attacks, right? The software supply chain, where the attackers are using AI to focus on the weakest underbelly. It's these developers who are rocking a MacBook without EDR and think that they're not they're not subject to your security controls. It's like, well, who else am I going to attack? I can steal all of your secrets on your Mac, and you never know the difference. And so I think those are going to be the areas that we've got to focus on. Harden our developer stack. Make sure that we've got appropriate at-speed detections of things like MCP servers, and then trying to bend the rules of the game so we don't have to lose.
Yeah. So as we look at things going forward, you mentioned a couple of things for roadmap for the future and things such as that. You'd mentioned about protecting ourselves, of course, the model context protocol, the MCP servers and things like that, the authentication between them and making sure that we track the flow. Anything else you can think of that you'd recommend that CISOs think about for going forward as part of their toolbook for dealing with this emerging AI threat?
So you need to think about first, what did Stryker teach us? Okay, so Stryker taught us that inappropriate hygiene on privileged cloud workloads results in 200,000 deleted devices. Okay, so you need to make sure that you've got just-in-time PIM, whatever you can do to eliminate persistent privileges in the cloud and persistent privileges for AI. Okay, so that means making sure that you've got something that allows for the proper elevation, the proper delegation, the proper on behalf of, and that gets you into parts of identity and access management that is not a commodity, right? Those are specialty skills, both at the developer level as well as the architect level and the operational level. So I would say invest in identity, right? And then I sort of mentioned this before. You have got to rein in your developers, right? The days of, hey, I'm a developer and I don't have to obey your security rules is done, right? That is inviting catastrophe. And so figuring out how you get those developers inside of your controls, and that includes their workstations, that includes their CI/CD pipelines, that includes their automations, and go and work with them to say, hey, how can we use AI to do security quality assurance on your stuff to help you do things faster, right? And so that's what I think the future holds.
Got it. Hey, in the last minute or two that we've got here, is there any questions that I probably should have asked you that I didn't ask that you'd like to comment on?
Oh man, I think the best thing to think about is if there's a cybersecurity truth that we're too uncomfortable to ask, it's basically AI is going to expose fundamental technology problems in your organization. I'm on a WhatsApp channel with a whole bunch of portfolio CISOs for private equity companies, and most of them speak very technical financial jargon, right? And so right now, someone said, "Well, is this a moment where we have to depreciate all of our assets and we have to move forward?" And it's like, boy, howdy! It's just like this is like your previous amortization table for an investment is done. It's baked, right? It's cooked, and so you're going to have to move forward and say, "Look, that sunk cost, that technology debt, right? We got to move on. We have to move forward. We essentially have to eliminate ourselves. And unfortunately, we don't have the luxury of time. And so you can either self-disrupt by doing this proactively and get off of that platform, or you will be disrupted. And so you get to make a choice right now. You have 6 months, I think, before we see massive numbers of updates coming down the pipeline. So now's the time for successful CISOs to basically say, hey, let's do a fundamental technology transformation to avoid the tsunami that's going to crush us from a vulnerability and exploit perspective.
Yeah, that's an excellent insight. I think, as you mentioned about economics and financial models, the sunk cost fallacy, which says, hey, I've already spent money on something. I got to get my money's worth out of what remains. It's very difficult sometimes. We've got to let me squeeze it out. And I might be guilty of such things when you get older technology and things like that. And I'm been driving the same car for 16 years and it was used to begin with. Well, come on, but it's already paid for as compared to get something that works for you. So I think going forward, Aaron, your insights are excellent, is that we need to start thinking a different model, that the old patch management doesn't work. By being able to have manual processes, it's not going to work. By relying necessarily sometimes on vendors to issue their patches, and then all of a sudden you've got 100 or 271 or however many changes were, for example, in Firefox 150. It's like, wow, how do you do regression testing and all that? It's a different thing. The next 2 years are going to be rough. And it means that we're going to have to adapt to new reality. If we go back to the old military analogies, it's going from kind of the muzzle-loaded thing where it takes a while and you get to and quickly flintlock because somebody's out there with a Gatling gun. It completely changes your tactics and things such as that. So it gives us something to think about. Thank you for everything you've done over all the decades now in cybersecurity and for your continued involvement in helping to add some leadership and some insight to what we're doing. For the rest of everybody out there, thank you for listening or watching CISO Tradecraft. If this has been part of your learning experience, let us know. Talk to us on LinkedIn. Give us a thumbs up if on the podcast channel, and we'll get back to you, and we'll happy to respond. Aaron, if somebody want to get in touch with you, what's the best way to follow up?
I'm on LinkedIn. Just send me a message, say, hey, heard you on the podcast, want to follow up on the ITDR stuff. I've got several research projects that I would love to have real world feedback on. So hit me up. Happy to get you involved in those.
Yeah, get some free labor on your part, but actually the research would be great. So thank you very much for being part of CISO Tradecraft. This is your host, Jim Mark Hardy. And until next time, stay safe out there.